Swayam Prabha. Digital India. Educated India.
Today we are going to study about the abrasive water jet machining process, which is one of the important processes in advanced abrasive machining processes. Till now we have seen in the previous class about abrasive jet machining, where the air is a carrier medium, but here the water is the carrier medium. That is why it is named as abrasive water jet machining. Overview of the lecture. So, introduction to abrasive water jet machining, then various elements of the abrasive jet machining process, parametric analysis of the and performance of this process, capabilities and applications of this abrasive water jet machining process we will see. So, this is the advanced version of abrasive jet machining, where as I explained in the previous slide, that the the basic problem is the divergence will be very high, because of the problem is the curve width whatever we want it may not achieve. So, you will achieve some stray width, some extra one, that is called stray cutting, and the other things will take place. To have a better cutting, for that purpose we use a liquid that is called normally water, so that we will have a coherent type of jet. Okay. So, that we all see in this one. Introduction. Abrasive jet machining is a mechanical material removal process, because the material removal is taken care by the abrasive action, that is nothing but abrasion, because of which it is used to called as a mechanical material removal process. And this erodes, basically abrasive particles erodes the hole which is exposed and cavities by the impact of abrasive particles and the slurry on the hard and brittle materials. As I said in the abrasive jet machining also, this particular processes are very good for brittle materials rather than ductile materials, because in the ductile material there may be a chance, or in a soft material there will be always chance that abrasive particles embed and it will create some problem. Okay. Since the process is non-thermal and non-chemical, because there is no temperature development, as the water will play as a coolant and the chemical action is not there, because water is not a reactive chemical. So, it is a non-electrical, it creates changes to the metallurgical and physical properties. That is why it will not create any metallurgical or physical properties of the workpiece. That means that the customer is expecting a parent material to be there at the hole site or a cavity site, you are going to achieve that one, because there is no thermal, there is no chemical and other reactions are there, because of which what the operator is going to get is no changes in metallurgical and physical properties. That means that the parent material properties will be there at the site of where the product is developed or where the hole or cavity is developed. Okay. In other terms, what I mean to say is that if you are going to machine a hole with a laser beam machine or electric discharge machining, so because of the thermal effects, what will happen? You will have a heat affected zone, recast layer, conversion layer and so on, where the microstructure is different, metallurgical aspect is different. In abrasive water jet machining, these thermal effects are not there, because of which what will happen is that there is no metallurgical changes compared to that laser beam machining or electric discharge machining. Okay. That is how one can understand if I can compare the two processes. In principle, this process is similar to abrasive jet machining process. As I said, except that in this case water is used as a carrier fluid in place of gas in abrasive jet machining process. The process offers advantage of cutting electronically non conductive as well as difficult to machine material comparatively rapidly and efficiently as with other process. That means that if at all I want to cut a electrically non conductive samples by EDM, it is not possible for that, and if it is difficult to machine materials, then it is very hard or very brittle or something, this type of materials it is very difficult to cut using the EDM process and other processes, but you can cut using abrasive water jet machining process. This is how the abrasive water jet machining looks like in the machining region. There will be a abrasive port, that means that abrasives are fed here and high pressure water will be fed from this particular place and both will mix. At the exit water is coming out and this is called orifice. From the orifice the high velocity jet of water is coming and abrasives are coming adjacent to it, both are mixed in the mixing tube and a abrasive water jet, this is called abrasive water jet, is going to impinge on the workpiece. Okay. So, used to machine non-metals basically. So, ceramic materials you can do, composites, rocks, metals such as copper, aluminum. Normally you do not prefer for copper and aluminum and other things because these are the soft materials, but you can always use it, but preferably if, since these are conductive materials, if you go for electric discharge machining and other things you can do it, but there may be a chance of heat affected zone, recast layer and other things. Okay. So, comparatively EDM is much better than abrasive water jet machining. If your requirement is partially metallurgical changes are there, then you can go for that one, otherwise you have to use this particular process. However, abrasive water jet machining you will have the problem of embedding of abrasive materials or abrasive particles on the surface of these soft materials. So, operations normally you can do drilling operation, cutting operation, deburring operation, all these things you can do. You can cut any kind of materials, high edge quality, adaptable for remote control, recycling of abrasives also possible, because in abrasive jet machining you do not have this flexibility of recycling of abrasives, because abrasives are getting fractured, and this is same holds good for this particular process also. At the same time there is a possibility of adherence of the workpiece material to the abrasive particles, which may make the abrasive particles dull, but here you have a carrier medium of water. So, the cooling ability is there and lubrication ability is there, because of which the chances of the adherence of the workpiece chips on to the abrasive particles is slightly less, but that is why you can recycle the abrasive particles in this abrasive water jet machining process. So, material removal mechanism, if you see, as you have seen the similar figure in the previous one, whenever the abrasive particles hit the workpiece. Okay. So, this is what is the machining region. If you take the machining region here, what is going to happen here is, if your jet is coming like this and this is your abrasive particle, this is abrasive particle and this is a carrier medium, that is water. Okay. So, you have many forces such as Fz, which is moving in this direction, Fy, which is makes the abrasive particle to move in this direction. So, because of this, what will happen, assume that this is my workpiece surface, Fz is going to put, see, if you can see here, what is happening is force Fy is responsible for penetration and Fx is responsible for removal of material. Here assume that normally the Fz, you can assume that it is Fx which is moving in this direction, Fy is indenting and Fx is moving in the direction of the carrier medium. That means that this is a radial force, Fy is a radial force and Fx is axial force. Okay. That means that along the direction of the water impingement, if it is moving, that is called axial direction. That is why Fx is called as a axial force, and radial direction, if it is perpendicular to the axial direction, that is nothing but indenting direction. So, that is called a radial direction. So, radial direction try to indent into the surface and axial direction try to move forward along the direction of your carrier medium, that is water, because of which what will happen, assume that this is my surface, my abrasive particle is indenting on this surface. So, Fx will try to move and Fy try to move in this direction, because of which what will happen, the chip will remove in the form of microchip, the material will remove in the form of microchip because of this radial as well as axial forces. So, for understanding the abrasive water jet machining, there is a visual examination is conducted with the moving camera. By tilting the workpiece on the nozzle, cutting wood takes place different. Two modes of material removal is observed. One is the cutting mode, another one is a deformation mode. Okay. Normally, the cutting mode will be done at the shallow angles of impingement, but the deformation normally takes at the large angles of impact. Okay. Penetration rate and depth of cut is a function of time, keeping other parameters as a constant. Okay. If you do like that, if you do the visualization, so basically the people have taken the perspex. Perspex is a transparent polymer material, just they have impinged the abrasive jet and they observe it, because as it penetrates it loses its energy and tries to go out, because this is the path that it follows. So, this is the intermixing takes place in this one, because of the abrasives are hitting some of the abrasives are at high kinetic energy, at the same time some of the abrasives are at low velocity, because it is already stagnant there, because of which what will happen, this type of path it is observed. Okay. The same thing if we can observe here, because of the jet drag and jet curve, as the abrasives moves through the material, the lower portion of the jet lags behind the upper section as shown in the figure. That is what, this is the jet which is coming out, this is the upper portion and this is the lower portion, another portion. Okay. So, as shown in jet curve is nothing but the width, thickness of the cut made by. Normally assume that this is the workpiece wherein we are cutting a slit of this thing. So, this is the width is nothing but the curve. Okay. How much thickness of the slit we are making or something is nothing but, or to simply to understand, assume that I have a surface on which I want to make a channel. Okay. So, I want to make a channel on the surface. So, if I make a channel of this is my metal surface, this is my metal surface and this is the micro channel, this is nothing but the curve. Okay. This is negligible for harder and thinner materials. Normally, the curve thickness is very fine in terms of harder and thinner materials, and the mechanism of material removal, if you see, as I discussed in the previous slide where the visualization is taken. So, this is the jet which is impinging on the surface, wherein it is following the track of the water. At higher junction, what is happening, it is having a higher velocity, as it goes down it will have a lower velocity. So, the cutting surface is taken care by the abrasive particle, and the energy that is getting will be from the energy that the abrasive particles gets is from the water or the liquid that people uses. Sometimes some people may use some other oils also, some of the papers they have used it. So, if at all some people are looking for the research and other things, you can use some of the mixing of the oils or blending of the oils and other things you can do. So, as you can see here, whenever the heating is taking place with respect to the workpiece, what will happen, this visualization which we have seen, same visualization is done for the particle and trajectories. Trajectory means the path how it will follow. Okay. So, as you can see the same phenomena here, if you have a development or the energy storage, if you are going to use at a different jet traversing and other things, as if you are using very less energy at the entry level or something, it will goes like this. Still, if you give a angular movement to it, it will take the path like this and so on. So, if at all the cutting jet traverse direction, if you see what is happening here is at the initial stage, it is the initial stage at the entry and it's move on. If you are going to increase with respect to time, what it is going to do is it is going to do the different cutting action. As you can see here also that the mechanism is gone inside. Working principle, mixing of water jet and stream of abrasives takes place in the mixing tube. Okay. The mixing tube will be there and where the abrasive particles as well as the water will mix together and make a suspension. Rapid rise in the abrasive velocity occurs at the mixing tube because the water is coming at very high velocity and the abrasives are fed from the abrasive feeder where this velocity of these abrasives are very less compared to this one, or the pressure at which water is coming is very high and the pressure of the feeding may be normally in abrasive water jet machining is due to the by the virtue of the gravity. So, because of this pressure differences and other things, the mixing will take place in the mixing chamber. When the impingement of the abrasives on the workpiece material takes place, the moment of transfer, that is kinetic energy of the abrasive particles will occur and the material removal will takes place by shearing action or erosion. In brittle materials, it will be like a brittle fracture. In ductile materials, normally it will be like shearing action or erosion. The pressure normally will be using is 400 megapascal. Jet speed will be like 900 meters per second, which is a high. So, normally whenever you see, whenever the abrasive water jet machining is operating, so there will be a symbol of our palm, hand. So, you should not put, if you put then gone. So, these jets can cut your fingers and other things. So, while those people who are using this one or something, they should be very careful about this particular machine because you close the system and I mean to say you close the doors, then you operate the machine. Otherwise, it will be danger whenever the operation is going on. It looks very easy. Sometimes it may be you cannot see also because the water is transparent color. So, there may be chance of accident. For that purpose, you should be very careful and you just close the doors before you start the operation. But however, just you can if it is a CNC controlled and other things, what you can just simulate it how the path is taking place and other things without jet. So, and once you close the doors, then you can operate the machine along with the abrasive water jets. So, cutting upper part of the is nothing but the kerf, which is the erosive action. At the same time, cutting in the lower part of the kerf is normally by the deformation. As you have seen it like this, it is follows. So, here is the cutting action in this region, and in this region normally it will be like a partial deformation process or something is the mechanism. So, working principle, if you see, the abrasives are fed from this. At the same time, you have a high pressurized jet with high velocity which is coming from this one. Okay. Both will mix in the mixing tube and you have a guard to protect. At the same time, mixing tube is here. So, this mixing tube is length and diameter plays a major role how about the mixing and other things, and this will hit on the workpiece and it will erode the material. The overview of the machine, if you can see here, this is the CNC control panel and this is abrasive tank. I already said that abrasive tanks are slightly on higher heights, because of which by virtue of gravity it will move and highly compressed water will be sent and both will mix and comes. So, you can see here jet is coming out of the nozzle, the abrasive water jet is coming out of the nozzle and it will impinge on the workpiece surface. Now, you can clearly see the aluminum material cut by the abrasive water jets, and you can see the how precisely it is cutting here in this region. At the same time, it is normally straight cut is taken place here, because it is a parting or some action is taking place. If at all you want to cut a complicated profiles, okay, so complicated profiles also you can cut, and these complicated profiles can be programmed by the CNC control and other things. Okay. So, this is a schematic diagram of abrasive water jet machining. Okay. So, you have a fluid supply, that is water is coming from this particular tank, and at the same time mixture and filter will be there. Then most important part here is the intensifier. Intensifier increases the velocity of this particular fluid or water which is coming, and accumulator will accumulate, and at the same time it will control and the send through the valve. So, whatever the pressure that you want, you can control by the valve and you can get the water. Suppose if at all I want to add the abrasive particles to it, you can add the abrasive particles along with the before the nozzle, you can use the abrasive feeding system. So, this is the schematic diagram is explained to you the water jet machining. However, if you want to add the abrasive particles, if you can add, so that it will convert into abrasive water jet machining. Okay. So, what I mean to say is abrasive jet machining you have seen where air is the medium to carry. In the water jet machining, water it will cut with water. So, if you club both to two, you will get abrasive water jet machining. Okay. So, the advantage of abrasive jet machining is you have the abrasives, you can cut, but the only problem with abrasive jet machining is that the divergence will be there. So, the stray cutting will be there. So, in order to counter it, what will happen? If you see on other side, there is water jet machining, the capability of water to cut is very less. However, coherent nature of water is there. So, if you can combine both the things, what will happen? The energy of the abrasives at the same time coherence of your liquid can incorporate both in abrasive water jet machining, and you can achieve greater performance compared to both individual performances of abrasive jet machining as well as water jet machining. That is why here you can see the water jet machining system, wherein if you can add the abrasive particles here, it will become abrasive water jet machining. So, the elements of abrasive water jet machining: pumping system, abrasive feeding system, abrasive jet nozzle, catcher. Okay. The pumping system, if you see the intensifier, normally 415 megapascal, 7.75 HP motor, normally high velocity jet can be done here. If you see the pumping system is most important system to generate higher pressures of water. In this one, what is the thing is, just you take the water source as well as you just pump into the intense pump with plungers into the pressurized water. Normally, this intensifier increases the pressure, it has its own mechanism, and you send to the accumulator where you can store for this highly pressurized water. Then you send to the nozzle. Before that nozzle, what will there, your abrasive feeding system is there. You can feed this abrasive feeding system. From here, highly pressurized water is sent, and from here you have the abrasives. Okay. So, the main important concept of here is the intensifier, which intensifies, or that means that which increases the velocity of the water, or it increases the pressure so that it can impinge on the workpiece by mixing the abrasive particles and other things. Okay. Elements of abrasive water jet system. The second element is abrasive feeding system. It delivers the dry abrasive particles, and to control the flow rate, the control orifice diameter suction mixing tube will be there. Okay. As you have seen in the previous slide, normally you have a mixing tube where it will suck as per the requirement. Normally, if you do not control much, what will happen, this will sucking will be done by the virtue of gravity plus the difference between the pressures. So, this is how the mechanism works. Normally, there are some other additional mechanisms that you can go, which can use like controlling orifice diameter and other things you can play. It cannot supply the abrasives for long distances because the pressure losses will be there in the tube unless direct slurry feed over the long distance. Now, that means that if at all I want to move the abrasive particles for longer distances, normally what you have to do is you have to make it slurry, then you have to send it. The water jet nozzle, normally the diameter ranges from 75 to 635 microns normally, and for higher life of nozzle, as I said, in abrasive jet machining also you have to go for sapphire material as a nozzle materials. So, this is the abrasive nozzle or abrasive jet nozzle. The functions of nozzle is mixing of the abrasives and the water, that is what is taking place. Here the abrasives are coming, at the same time here the compressed water is coming. So, both are mixing here. This is a mixing region which is a green color, and it is impinging. So, practically how you can see here is this one. So, this is the abrasive feeding system, water feeding system, both will mix in this particular region and it will impinge onto the workpiece. So, mixing of the abrasives is one of the functions, and the forming of high velocity jet, that is abrasive water jet, is another function of this abrasive jet nozzle. The materials, as I said, tungsten carbide can be used, boron carbide also can be used, sapphire is normally used. So, if at all you want for longer life like 300 hours in abrasive jet machining, which you have seen, sapphire will be used. If at all you want to use for 30 hours or 25 hours, normally tungsten carbide based nozzle jet materials can be used. Okay. So, these are the nozzles normally you can see, and you can see the anatomy of these particular nozzles, where this is how the schematic diagram and practically how it looks like. This is for your better understanding purpose, and this is a complete nozzle, how it looks like as a whole. Okay. The same nozzle, this is the same nozzle, just to show you how it will be look like in a complete way. Okay. This is a schematic where water chamber is there, abrasives are fed. This is the abrasives feeding, this is the water is coming with high intensity, and abrasive water jet is coming out of this one. So, this is how the abrasive water jet will come out of the abrasive jet nozzle. These are the other varieties of nozzles where you can play with the stand-off distance. The stand-off distances are varied. If you go for a small nozzles, it will be different. You can see in this particular nozzle, this is how the abrasives are fed. In some cases, here is the abrasives are fed. Some cases you can feed perpendicularly. So, how you want you can feed. So, there are multiple jets. You can see this is the multiple one. You can have a multiple abrasive jets, and you have a water jet. So, this is how you can play, depend on your application, whether you want to go perpendicularly, whether you want to go certain angle. This optimization of this study also may be a good thing. How to feed? Assume that my water is coming like this. At what angle if I can feed my abrasives can be a good study also. Okay. So, some people might have studied already. So, you can see those papers and you can study also. Okay. This is the water jet which is coming, and abrasives, how you can feed the abrasives. Okay. So, if you feed against the flow, normally the jet velocity may be drastically changes. For that purpose you should look into it, maybe the mixing may be better. Okay. So, you can compromise on the mixing ability as well as the velocity and other things you can work out to take. As a BE Tech student, some people, if you are looking at and if you have this abrasive water jet machining facility, so you can go for the optimization of the angle of abrasives feeding to the angle of the water jet coming. Okay. So, you can make the performance, assume that your performance is surface roughness, if your performance is material removal or surface morphology and other things, you can study as output responses for the angle of feeding of abrasives with respect to angle of the water jet. The elements, another element is the abrasive water jet nozzle. If you see, there are the single jet side feed nozzle, that means that water is coming from here and the abrasive particles are fed from here. Okay. So, both are mixing in this area, you can see the mixing is taking place here and it is moving forward. So, the abrasive water jet is coming like this. So, this is simple to make because you have the one tube and inside you have another tube wherein the water is coming, abrasives are coming and mixing, and rapid wear of exit part of the nozzle. That means that if you have a nozzle, the exit part, this particular portion will get weared out. So, non-optimal mixing efficiency of water and abrasive particles will be a concern here. So, second one is annular jet central feed nozzle. If you can see here, abrasives are coming at the center. Previous nozzle you have seen the water is coming at the center and abrasives are coming from the sideways. Here what is happening here is abrasives are coming from the center and water is coming from the outside. So, now the mixing is taking place and the abrasives are coming like this. Okay. So, better mixing of abrasive particles and water will be there compared to the previous nozzle, and mixing is outside the nozzle. So, it will be better. At the same time, the basic problem here is less accurate machining. That means that because of the water is coming out and abrasives, so abrasives will split the water jet. Assume that what is happening is as 1 mm diameter water jet is coming, if you are feeding the abrasive particles at the center, what will happen? The jet will try to diverge. Okay. So, that is why less accurate machining will be a problem of this particular nozzle. So, that because of which what will happen, the cuts are slightly wider as per the requirement. Assume that what is happening, if I want this particular micro channel or milli channel, what will happen, you may get slightly wider one. Assume that instead of 1 mm channel you may get 1.05 mm or something. So, that is a disadvantage of this particular nozzle. So, another nozzle system is multiple jet central feed nozzle. If you see here, you have a multiple jets of water. Here jet is coming, one jet, here one jet is coming. Previous case, this is only one jet, but the water source feeding is same. In the abrasives are coming at the center. Okay. So, this one centrally located abrasive feeding system is there, as you have seen in the previous one, surrounded by the multiple water jet converging into annular regions and higher nozzle life and better mixing. Because what is the main concern here is that if the water is on outside, if the water is coming, if you concentrate in this particular section, water is coming like this and abrasive jet is coming like this. So, that the advantage is water is in contact with the nozzle material, not the abrasives. but there will be chances of abrasives will also come into contact, but the chances here is water come mostly in contact with the nozzle. So, the nozzle life will increase enormously. However, this process this nozzle is slightly costly and difficult to fabricate, because you have a multiple water jets and other things are there. So, you need to do lot of micro machining work and other things. Okay. The another part of this abrasive water jet machining is catcher. So, catcher, many people how to catch the ball in a cricket and other things. So, here also you need to catch the jet, because the jet and abrasives are coming at very high velocities. If you do not properly receive it, what will happen beneath the cutting material or the beneath the workpiece, it will also cut. So, normally what you will have is the workpiece will be held, and below that you will have a catcher. That means that there will be a water tank normally or some bags wherein it will absorb the velocity of the water and it will sediment the abrasive particles. Okay. So, the stationary nozzle and moving workpiece, in this is the one condition. Assume that this is the workpiece that is moving. In this case, nozzle is stationary, but workpiece is moving. Like workpiece, as you can see here, it is reciprocating or traversing, and the nozzle is at the same location. In this one, long narrow tube is placed under the point of cut. What will happen? The abrasives and water is coming from here, it is cutting and it has to go. So, as we have seen the path of the abrasive water jet, so this will follow the similar. So, you will have a catcher which is a bag in the similar direction, where you can see the obstruction to reduce the energy. You will have all the obstructions. This bag will provided with some of the obstructions. These obstructions will obstruct the velocity of water, obstruct the velocity of the jet also, and it will exit. This is one of the way of which is one of the way of catcher, and normally what you can see in most of the abrasive water jet systems is this type of thing, which is moving nozzle and stationary workpiece. The workpiece is stationary and the nozzle will move. In this case, what is happening here is you will have a complete water tank. Since you are using water as a carrier medium, you will have similar type of water as a catching medium also. This is economic. A water filled settling tank underneath the workpiece will be always placed, and a transparent high pressure to the water filled tank will be there. To collect the remainings of abrasive water jet, always you will have a flexible hose, at the same time rigid tubing. You can go for flexible hose and rigid tubing also you can use. Normally what you can see in many cases, there are many abrasive water jet machining people in India itself. If at all you are interested, the first and primary person you can visit is Professor Ramesh Babu, IIT Madras. You can visit his lab. So, he is one of the expertise in this particular area. At the same time, IIT Kanpur also this abrasive water jet machining is there. So, you can see not only this, these are the few things which I have seen in my life, and in many places it is there. So, if you go anytime for the quality improvement programs or any other things, if you are a PhD student or master student, if you are doing, try to do in the advanced areas, and you can go for micro cutting as well as texturing of this jets and other things. Okay. So, whatever the thing is that if at all you want to go for this type of moving nozzle and stationary workpiece, you just put the water tank with the water. Because of water and the water jet is coming, it will catch, and the water has certain resistance to the jet. So, this water jet will die off once it enters into the tank. So, parametric analysis of abrasive water jet machining, normally if you see the fishbone diagram, that means that how the output responses like machining rate, quality of the cut, kerf quality, depth of cut, all will vary with respect to the workpiece materials. Okay. So, the first parameters are the abrasives. So, the size of the abrasive particle normally mentioned by the hash symbol, type of the abrasive particle, that is whether it is silicon carbide, whether it is a alumina, whether it is diamond particle or something is another factor. At the same time flow rate, how much flow rate you are using, whether you are using 1 kg per hour or 10 kg per hour, at the same how flow is taking place, and at the same time flow rate also the same thing will be handled here also. So, the flow rate as well as how far the pressure of the water is you are sending. So, the abrasive feeding nozzle material, as I said, whether it is tungsten carbide or sapphire or something, because it will decide the life of the nozzle, and the cross section, whether the cross section is a circular cross section, whether the cross section is a rectangular or a square or something, you can decide. And water nozzle, the cross section of the water nozzle also play a major role. Material, and since here also you can go for less harder materials. The feed rate, the cutting parameters, that is input parameters, normally what you can put into the machine, that is how much feed rate, number of passes, whether you want 10 passes to cut the material. If the thickness of the material is too high, you have to go for more and more number of passes. Angle of cutting, whether you want 2 dimensional, you just go perpendicularly, whether if you want to 3 dimensional structures, you have to give certain angle of to the nozzle, and the stand up distance or nozzle tip distance, that means that how much distance that you have to keep with respect to the workpiece material. Assume that this is a jet, and how much distance, this is a workpiece and this is a jet. So, whether you want to go for 5 mm, whether you want to go for 50 mm, or this distance you can also play. The workpiece material, the workpiece hardness, if the hardness is very high, normally the material removal will be very less. The material properties like yield strength and other things, brittle or ductile, if the material is brittle, the mechanism of material removal will be brittle fracture, then fragments. In the ductile material, just shearing action will take place. So, mixing tube, normally mixing tube length plays a major role as well as the diameter. If the length is too high, what will happen, or the length is too long, the velocity of the jet will die. If the diameter is very high, then the mixing also will take its own time or something. So, these are all the parameters that will affect the output responses. Some of the papers whenever we review or we see, so some of the students write output parameters and other things. Be careful about the parameter and response. Okay. When I called this flow rate, abrasives, abrasive feed nozzle, water nozzle, workpiece material properties, cutting parameters and mixing tube, these are all parameters. Parameters means what you can change, what operator can play. These are the parameters that you can change. Responses means which you cannot play. These are the things that are come or the outcome of the process. Okay. So, the responses is only you can observe, you cannot vary those. By varying the input parameters, you can vary the output responses. The responses means these are the responses that you have to take note down, that is all, you cannot vary. Okay. So, that is the difference between input parameters. You can vary the parameters, that is why it is called input parameters. If you want to say output parameters, that is a wrong word. I cannot say completely wrong, some people uses it still. So, that is my observation, what I learned from my professor. So, output responses, please do not use the word output parameters, because parameters is what you can change, responses is what you cannot change. Output is what you will observe, input is what you vary. Okay. So, that is the difference between input parameters and output responses. Process parameters, water, flow rate and pressure, what we have seen, abrasives, type, size and flow rate. These are the parameters from the fishbone diagram, all the parameters which we cannot take. So, some of the parameters which are important, sometimes you see you do the design of experiments and you come up with percentage contribution of input parameters. What you have a set of fishbone diagram input parameters, among which what you have to do is you just see the percentage contribution of each input parameters which are playing a major role, those are to be considered. So, from the literature what the authors observed is water flow rate and pressure play a major role, abrasive type, size and flow rate play a major role, water and abrasive jet, materials and design, cutting parameters like feed rate and stand up distance plays a major role, and workpiece material, whether it is a brittle material or a ductile material, mixing tube diameter as well as length, as I said, this plays a major, and angle of cutting, whether you want to cut a 3-dimensional or 2-dimensional and other things, traverse speed, how fast, whether if your nozzle is moving, how fast the nozzle has to move, if the workpiece is reciprocating or traversing, how fast the workpiece has to move, and the number of passes. If at all I want to cut thick materials, so I need to go for more number of passes. So, abrasive water jet pressure, so minimum pressure which is nothing but the critical pressure. Okay. So, need to start the cutting of the material, this is the critical pressure. If you see the picture, this is the critical pressure. So, critical pressure means beyond which the material starts cut. Okay. So, if you see here, the pressure is there, abrasive water jet pressure, the depth of cut. At this particular point 1, there is no depth of cut, that is why that particular point is considered to be critical pressure. As you increase the pressure, what will happen? All the curves are increasing, that means the depth of cut is increasing, because if the pressure increases, what is happening? The kinetic energy of the abrasive particles that gains from the water will increase, because of which what will happen? Your depth of cut will increase. If you increase the abrasive flow rate, that means that more and more number of abrasives are there, what will happen? The more and more cutting edges will come into picture, so the material removal takes place. In the first case, you observe any one curve, as your abrasive water jet pressure increases, what will happen? The kinetic energy of the abrasive particle will be more, that is why all the curves will increase. If you see across the curves, like what the arrow is showing, this particular arrow is showing. So, if your abrasive flow rate increases, what will happen? Number of abrasives coming into contact with the workpiece will increase, so the depth of cut also will increase. So, water jet pressure, critical pressure, as we have seen in the previous slide, below this pressure stresses developed in the workpiece material are lower than the yield stress, that means that material removal will not take place, because the yielding itself is not taking place. So, below this pressure no cutting takes place, because yielding of the material is not taking place. Different for different workpiece materials, this critical pressure, if at all I want to cut the hard materials like stainless steel, your critical pressure will be different. If you want to cut aluminum, the critical pressure will be different. That is what depends on workpiece properties, that is hardness and ductility and other things. Above a definite jet pressure, what will happen? The machining depth tend to stabilize, because after certain value it starts stabilizing. Relationship with the machine depth, steeper with the higher abrasive flow rate. Now, normally what I mean to say, if you are going to have more flow rate, what will happen? More and more material removal will takes place, more and more steep it will go. Increased pressure will lead to lower efficiency, at the same time higher nozzle wear rate, because if you are going to increase the pressure of the abrasive water jet, what will happen is these abrasives may collide each other, at the same time the impingement of these abrasives on the nozzle surface, or I mean to say nozzle inner surface will be more, and the wear rate of the nozzle will increase. Water jet pressure, if you see in this one, the critical pressure, is nothing but where the material removal is yet to start. So, as you increase the water jet pressure, same thing, the kinetic energy of the particle will increase, that is why it will increase. Normally, if you see the D1 and D2, if the D1 is more than D2, the depth of cut is more. That means that if your diameter is more, what will happen? the width of the cut will be increased. What I mean to say, if this is the nozzle diameter, in another case this is the nozzle diameter, and the abrasive flow rate is same. If you say the abrasive flow rate is same, what will happen here, whatever the abrasives are coming, it will cut the workpiece steeper. That means the depth will be steep. Here what is happening, this is the workpiece, for the same flow rate you may achieve this much depth only. Here what you are going to achieve is this much depth. That is what the depth of cut in the smaller diameter will be high. So, the abrasive jet machining, where the gas is used as a propelling fluid, abrasive water jet machining, you will have the water. Normally water enables high abrasive flow rate, normally 0.125 kg per minute, which is a very high value, can be achieved, and it is possible to accelerate the abrasive to the velocities over the 300 meters per second. If that is the velocity, then it can cut the materials like stainless steel, it can cut the aluminum, it can cut even glass and other brittle materials also. Abrasive jets are more suitable for cutting the compared to the gas abrasive jets because of the more coherent jet. That is what I was telling is, compared to the jet, what is happening in this condition is the jet is coherent. I mean to say, in a abrasive jet, what is there, once it comes out of the nozzle, there will be a chance of diverging because air is there. In the other condition, if it is coming, water is coming, what is happening is you get a perfectly coherent one. I mean to say, not 100%, just you will get a coherent beam. That means that in a straight line you will get, because of which what is happening is you will cut a perfect cut into the material. So, the water flow rate is proportional to square root of the pressure and the square root of the diameter of the nozzle. Okay. So, increase in water flow beyond a certain value may result in insignificant gain in the particular velocity. Higher pressure loses the supply lines, unacceptable environmental conditions and other things. If you are increasing beyond certain value the pressure, what is happening is the particles will collide each other and loses their velocity. At the same time, this will impinge the abrasive particles on the inner walls of the abrasives, inner walls of the nozzle, so it will damage the nozzle also. Abrasive particles, abrasives are those materials which are used normally. If you see here, normally in the abrasive jet machining, the economical is granite, sand, silica. These are the type of abrasive particles will be used. Abrasives come in different particle sizes, that is the grit sizes depend on how much material you want to remove. If the material removal is very high, you have to go for coarser one. If your material removal rate is less, then you have to go for finer. If you are going for finer, then the cut of the machining is much finer and you will also get the surface finish. Optimum particle size, the finer particles normally used for the shallow depth of cut, the coarser particles for high depth of cut, and different abrasive sizes for different depth of cut you can use. Abrasive materials, normally machine depth is a function of type of abrasive particles. That means that if at all I want to go for higher depth of cut, then you have to go for much harder workpiece material, much harder abrasive particles. If I want to cut deeper cuts, then I have to go for the much harder abrasive particles. As you can see, the grit size normally 8 to 24 considered to be the coarse, that means that very big size of abrasive particles. Then 30 to 60 you will say that is a medium, 70 to 80 will be fine. At the same time 220 grit size to 1200 grit size will be like very fine. Okay. Normally people will measure in terms of sieve and other things, which I have explained in the grinding process. This particular sieving and other things is number of the abrasive particles passing by the sieve, will say the grit. Okay. This particular one portion is nothing but a grit, one grit. The commonly used abrasive particles are in the ranges of from 100 to 150 grit, and there is an optimum particle size for a particular workpiece material and also for a particular nozzle mixing chamber configuration. Normally, if at all I want to do particular operation, then I have particular nozzle specification, particular abrasive particles and other things. So, the abrasive flow rate, normally machining depth will be proportional to the velocity of the flow rate, and normally mass flow rate is very high, it reduces the depth. If the mass flow rate is very high, that means that the abrasives are more and more abrasives are coming through the nozzle. So, the abrasives will collide each other and there will be a loss into the velocity carrying, and in case of machine flow rate, wear of mixing nozzle will takes place, at the same time mixing efficiency will reduce. That means that mixing will be high, the wear rate of the nozzle will be high because of the more and more abrasive particles are coming in contact with the inner walls of the nozzle. At the same time mixing efficiency will go down because the abrasive particles will collide each other and may move apart or some. Okay. Selection of the type of abrasives, normally it will be done based on the cost of the abrasive particle, nozzle wear rate, at the same time environmental considerations and machining rate. If I want more machining rate, normally hardness ratio should be very high. That means that your abrasive particle hardness should be much higher compared to your workpiece hardness. So, the abrasive flow rate, if you see the abrasive flow rate, normally the depth of cut, as I said, if at all I want to cut a mild steel material, if glass beads very less, then the silica sand, granite sand and alumina. If at all I want to go, then I have to choose a better hardness value, that is called hardness ratio. As I spoke in the previous slide, okay. So, hardness ratio is nothing but abrasive particle hardness versus by the workpiece hardness. So, this hardness should be much bigger. If the value is more, that means that abrasive particle hardness is high. Okay. For the same workpiece material here, if your hardness of your abrasives is increasing, then the depth of cut that you can cut will be normally increasing. Abrasive flow rate versus number of phases, if you see the depth of cut, the abrasive flow rate, if the abrasive flow rate is, as the abrasive flow rate increases, what is happening here is, for the cast iron, which is a brittle material, the depth of cut is very high. The mild steel and the stainless steel is much harder ductile material compared to the mild steel. That is why the depth of cut in the stainless steel is good, at the same time mild steel is lower, because the mild steel is a ductile material, there will be always chance of accumulation of this particular materials. At the same time number of passes, as the number of passes increases, as I said, your depth of cut, cumulative depth of cut will be continuously increasing. If you see the grit number, if the grit number is increasing, that means that abrasive is becoming finer and finer. In that circumstances, what is happening here is, you are going to perfect cuts, the surface roughness what you are going to get is good in that circumstances. If you see here, the grit number is 60, so the cumulative depth of cut is very less. At the same time, if you see for the 36 and 16, you are going to achieve approximately same cumulative depth of cut. That means that if your abrasive particle is big, if the grit number is less, that means that the abrasive particle is slightly bigger. If the abrasive particle is coarser, what is happening is, depth of cut that you are going to achieve is higher. Traverse speed, depth of cut decreases with respect to increasing the traverse rate. That means that if your traverse rate is increasing, that assume that my nozzle is moving, at the same time workpiece is stationary. In that case, if the velocity at which the nozzle moves, what will happen, if nozzle movement is very fast, the insufficient time will be there for cutting the workpiece material. That is why the depth of cut will decrease. So, overcut decreases with increasing traverse speed. That means that it don't have sufficient time to cut. That is why the overcuts will be always reduces. So, traverse speed versus area generation rate as the optimum range. That means that if you see the traverse rate versus area generation, that is how much area you are cutting. So, initially it will be less, gradually it will increase, then it will decrease. So, as a operator, what you have to do is you have to choose optimum range of traverse rate, so that in this region if you are going to operate, what are you going to get is you will going to get more and more depth of cut. Number of passes, if the number of passes are multiple passes, single water jet with multiple passes is possible, multiple tandem jet with a single pass is also possible. Each jet makes an additional depth of penetration. Normally jet 1, if you see the picture here, so jet 1 gives H1 and jet 2 gives the H2, normally H2 minus H1 mm, and the jet 3 gives H3 minus H2 mm. This is the additional depth in terms of multiple tandem jets with single pass. So, increasing number of passes, normally cumulative depth will gradually increases. So, the kerf act as a local mixing chamber. Okay. So, this is about the multiple tandem jets with a single pass. So, you can see the H1, H2, H3 is the depth with respect to the jet 1, jet 2 and jet 3, that is explained in the above. So, the number of passes, if you see the number of passes as it increases, cumulative depth of cut obviously it will increase. And if you see the traverse speed, if the traverse speed is high, what will happen? It has insufficient time to cut the material. That is why if the traverse speed is very high, what is happening is TR1 is greater than TR2. In that circumstances, what is happening is TR1, that means that in this TR1 case, the nozzle is moving at faster rate, so it has insufficient time to cut. TR1 velocity 1, TR2 is velocity 2. So, velocity 1 is higher than velocity 2, because of which what will happen here is the movement of the nozzle is very fast in this case V1, the movement of in the other case it is less, because of which what will happen, here in this condition what is insufficient time is there to cut the material compared to V2. That is why your TR2 will give you more material removal in terms of depth of cut. Stand up distance is sometimes in some of the textbooks they will say nozzle tip distance also. If the stand up distance is increases, what is happening is the distance between nozzle exit and the surface, workpiece surface will increase. If you are going to increase, what will happen, the velocity or the pressure that is carrying, the pressure difference will be more and more, and if the pressure difference is reduces gradually, if the distance is increasing, then the depth of cut will be gradually reduces. So, at the same time, rebound of the particles and loss of energy gives the shallow depth of cut if the distance is more. Beyond the upper value of stand up distance, no cutting will take place. If the stand up distance is too high, the pressure that carries from the nozzle exit will be dramatically reduces, because of which there won't be sufficient energy for the abrasive particle to cut the material. The smaller stand up distances gives the deeper depth of cuts. Obviously, if the nozzle distance and the workpiece is too nearer, what will happen, it can cut deeper and deeper holes. If the nozzle distance and this will be very high, what will happen, the velocity that will carry, the kinetic energy will be very less, so it may cut very less depth of cuts. Okay. So, the kinetic energy will play a major role in terms of stand up distances. If the kinetic energy of the particle is very less, as the stand up distance increases, what will happen, the depth of cut achieved is very less. Variation in depth of cut with the penetration rate, as you can see, the penetration rate means always it is a function of with respect to time. If you see the time with and the depth, cumulative depth normally will gradually increases if your machining time will increase obviously. So, if you see the penetration rate, if the penetration rate is if the time increases, what is happening is the penetration rate, that means that hardness of that particular surface will gradually increases, because indenting, stain hardening will takes place, and the surface at that particular position will goes on increase. At the same time, if your depth increases, what is happening, the nozzle tip distance or the stand up distance will also increase, because of which what will happen is the penetration rate will decrease. The process performance of abrasive water jet machining, it can cut thick materials about 200 mm, which is a good amount of depth of cut. Kerf width decreases with workpiece hardness increment. That means that if the workpiece hardness increases, what is happening is the kerf width decreases. And machined surface, no thermal and mechanical damage, because there is no heat generation and other things. Machining of the glass, normally stray cutting leads to frosting of the surface. That means that you can make some surface texture also along with the machining. So, the advantages of this particular process, this is practically no dust, as some of the people says at this particular point of time. I remember one of the scientists was explaining, in one of the developed countries, what is happening here is the dust generation. Suppose there was a asbestos company or some company, the cutting was done with a slit saws, that means that very thin grinding wheels. Because of this mechanical action, what is happening is dust production is very high. So, environmental concerns came and the company has to forcibly close. For that purpose, what is happened is later the same company came up with abrasive water jet cutting and water jet cutting techniques, where if you instead of cutting with the slit saws, now they are cutting with the water jets or abrasive water jets. Whatever the dust that is generated in the slit saw based machining, here it is not generated, because the dust also carried away or captured by the water. That is the beauty about this process, and this process is sustainable from the environmental point of view. That is the beauty about this process. So, you should understand the environmental aspects also of this abrasive water jet machining. In this aspect, I would like to appreciate this particular process from the operator's point of view, from the environmental point of view who are living around the surroundings. High cutting speeds, you can cut with high speeds compared to abrasive jet machining, compared to water jet machining. The multi-directional cutting capacity, you can cut in any direction, incline direction, perpendicular to the surface and other directions. No fire hazards, no thermal or deformation stresses, because water will act as a coolant as well as lubricant. High quality of machined edge, that means that there won't be any radiusing or something, because your jet is moves along the direction of what you are giving, because the jet is coherent enough, so that you will get the perfect machined edges. Easy to adopt and for the remote control, that means that you can operate it inside the chamber or inside the system by controlling the CNC. Recycling of abrasive particles will be always there, because there won't be adherence of workpiece chip materials to this one, because you have the water which lubricates the abrasive particles and as well as cools the workpiece material. So, there won't be any high temperature generation as well as the adherence of the workpiece material to the abrasive materials. Low power requirements, if the power requirements are very low, because your penetration depth is high compared to your abrasive jet machining. If at all I can achieve 20 mm with abrasive jet machining, if my power is P1, same 20 mm depth you can achieve less than P1 in abrasive water jet machining. That means that your power requirement compared to abrasive jet machining, power requirement compared to water jet machining will be always less in case of abrasive water jet machining, and almost no delamination and reduces the strains also. Applications, if you see, Water jet cutting can be employed for decommissioning of nuclear facilities, which is one of the good thing. Normally nuclear facilities and other things are very delicate to do the decommissioning and other things. So, this particular process can do that application. So, the optimum performance has been reported normally with 0.38 jet at 200 megapascal with abrasive flow rate 54 kg per minute. This is one of the researchers' conclusions. In some of the cases, this technique has proved to be economical compared to the conventional bulk material removal methods. That means that conventional grinding or conventional cutting and other things, the energy may be very high and the cost of the production also very high. So, compared to that process, abrasive water jet machining is economical. Slotting is one of the common applications. Various steels like stainless steel and other special alloys can be cut by abrasive water jet machining. Kerf width normally observed are in the ranges of 0.75 to 2.25 mm, which is a very good if at all you are going for macro cutting or the milli cutting. Roughness of the surfaces vary with respect to depth of cut. And so, if you can see the applications, normally you can use for the paint removal, cutting of soft material, cutting of the frozen meat, textile. Normally this you can cut frozen meat and other things you can cut using not with abrasive water jets, you can cut with the water jets, and you can use for the pinning, cutting and other things. These are some of the applications that are cut by the abrasive water jets. Very fine cuttings also can be done using the CNC controls. This is what taken from Professor V.K. Jain's laboratory, which is a manufacturing lab, and this particular cut is available, as I said, that IIT Kanpur has this abrasive water jet cutting and in the 4I laboratory. So, applications, you can see this is one of the applications that is taken from IIT Madras. Thank you to the Professor Ramesh Babus, and these are the delicate cuttings. You can see the butterfly, or you can see the deer, and all these things can be cut on metals. At the same time, it can also cut on granite. You can see the thickness of these particular surfaces. You can cut a very beautiful sculptures on the granite also. Okay. Summary of this particular class, you can see introduction to abrasive water jet machining is studied, various elements of abrasive jet machining, various elements of abrasive water jet machining is done, and parametric analysis of abrasive water jet machining process performance of abrasive water jet machining, process capabilities and applications we have seen. So, I am very thankful for Professor V.K. Jain for this sharing his slides generously without any hesitation, because most of the slides I have prepared from Professor V.K. Jain's slides. So, I am very thankful to Professor Vijay Kumar Jain once again for his kind support by sharing some of the slides. Thank you for your kind attention.